Hello, so today I will solve this problem from AP 2003, Calculus BC. So this is from 2003 Form B, and this is number 5. So when we read here, we know that this is graph of f, this piecewise function graph, and we're given that the function g of x equals the integral from 2 to x of ft dt. So this is really important right here, that relationship. Now we can move on because we got all of the information we need. So we need to get g of 3, g prime of 3, and g double prime of 3. So we learned that g of x equals the integral of 2 to x of ft dt. So using this, we can get g prime of x and g double prime of x. So because from g of x to g prime of x is differentiating, so if you differentiate here, you get f of x. Because of the fundamental theorem of the derivative number 2, when you do the differentiation of this integral form, you drop the variable and then multiply by the derivative of the one here, and in this case it's x, so the derivative of x equals 1, so there's no change but just replacing x with t with x, like that. And again, from g prime of x to g double prime is the derivative, so in this case it becomes f prime of x. So now we know the definition of g of x, g prime of x, and g double prime of x. We can easily get g3, g prime 3, and g double prime 3. So g3, you just plug in 3 to the x here, so it's ft dt of the interval 2 to 3. So 2 to 3 here is right here, this whole area. So we can use the trapezoid rule and get the area of it. So it's 4 plus 2, which is 6, times 1 divided by 2. So the area here under the graph of f equals 3. And g prime 3 is fx, so which is f3, right? F of 3. So we just have to get the y value of the f in the f graph. So f3, f equals 2. So g prime of 3 equals f of 3, which is 2. And g double prime 3 equals f prime 3, which means the slope when x equals 3 in the graph of f. So here we can use rise over run. So a run from 2 to 4, it drops by 4. So negative 4 over 2 equals negative 2. So we got all of these by using the relationship. Now we can move on to B, part B. We have to get the average rate of change of g on an interval of 0 to 3. So average rate is basically getting the area of that within that interval, so from 0 to 3 ft dt divided by the interval beta minus interval alpha, which is this case 3 minus 0, because the average rate is basically getting the average height of this whole area. When you bring them down, it will feel like some rectangular shape. We're trying to get that height. So that's what it is. So we have to get the area and divide it by the base, that we get the average height of it. So from 0 to 3, FTDT is this whole area right here, including this triangle and the trapezoid we just got right here. So the triangle here is 4 times 2 divided by 2, which is 4, plus the trapezoid we got is 3 over 3 minus 0, which is 3. So the average rate of change of G on the interval of 0 to 3 equals 7 over 3. And next stage is part C. So in part C, we have to get the value C when G prime C equals the average rate we got. So this is really simple. We have to just put as G prime C equals 7 over 3, right? And we learned that G prime C can be rewritten as Fx, which is Fc in this case. So we have to get C where the y value in the F graph equals 7 over 3. So 7 over 3 can be rewritten as 2 times 1 over 3, right? So y should equal 2 times 1 over 3. So let's say that is right here, this horizontal line, this red line. So points where the graph of f and y equals 7 over 3 intersects are these 2 points. So that means only those 2 points, those 2 points are C value. So only those 2 are the possible value for C, because only them, when you plug in, this makes sense. Fc equals 7 over 3. So part D now. Part D. Find the x-coordinate of each point of inflection. So point of inflection is where the concavity changes. So basically the double prime should equal 0, and based on that 0, from left to right, the sign should change to the opposite sign. So point of inflection of graph of G is what we have to find. So that means we have to find the point where G double prime x equals 0, and that means f prime x equals 0, right? So we have to get f prime where the point x when f prime x equals 0. So that means slope in the graph of f equals 0. So if you look at the graph right here, the given graph, we can see that at 2, right here, at 2, the slope is horizontal, and at 5, the slope is horizontal. So we got this 2.2 and 5. So 2 and 5 is the x value when f prime equals 0, which means g double prime equals 0. So those two, x equals 2 and 5, are the possible candidate of the point of inflection. But before we conclude, we have to check first. This is called second derivative test. So what you do is just checking the sign, plugging in some certain value that's smaller than 2, this in between 2 and 5, and a value that is bigger than 5, and then get the sign here of each range and see if the concavity actually changes. So for example, below 2 we can put 0 in it. A 0, this case is is increasing, so that means it's positive here. And then after 2 it starts decreasing, which is negative. Then from 5 it increases again, which means this positive. So when you see here sign changed from positive to negative after passing point 2, and if the sign changes from negative to positive after the graph passed through the x equals 5. So that means at x equals 2 and x equals 5 the sign changes, which means the concavity changes. So that tells us that x equals 2 and 5 is where point of inflection exists. Thank you.